this detailed video, we are going to illustrate the ARW-1920S coating thickness gauge, which is a professional precision device designed for measuring the exact thickness of a coating layer. As we can see, the instrument is housed inside a sturdy ABS plastic carrying case, which is shockproof and therefore ensures the internal device is well protected. Inside the case, we find the documentation, the main body of the instrument, regarding the thickness standards. There are 5 different calibration foils used for accurate calibration, which we will see later on when we go over the features, how it works. The package includes 2 different zeroing bases, one ferrous and one non-ferrous. So there will be a solid carbon steel base and a high-quality aluminum base, both of which are metallic bases. Then we have the probe, which is a highly advanced dual technology probe system. It works perfectly on both ferrous and non-ferrous substrates, including carbon steel, stainless steel, or various types of aluminum. Another important cable included is the PC connection cable. This professional instrument features advanced data management, a very large memory, and the ability to transfer all data to a PC. This is done with a specialized program, which is a standard supplied software. On our website, directly on the specific product page, you can download the software. To complete the set, you will also find a handy screwdriver included, which allows you to easily unscrew and remove the battery compartment. Now let's take a look. Let's take a look in greater detail at the various functions and features of this thickness gauge. As we mentioned earlier, the thickness gauge is specifically designed to accurately measure the thickness of a protective coating or surface layer on both ferrous and non-ferrous metallic substrates. The very first step in the process is to properly connect the external probe to the device. The probe features a specialized connector that, once you locate the correct slot, you simply push in and the connection is securely made. This probe, as we previously mentioned, is a dual technology FN probe that allows you to measure both on ferrous and non-ferrous materials, specifically on metallic substrates. The very first thing we definitely notice when we power on the device is the main screen. First of all, it is a vibrant color screen, and it is also a very comprehensive screen in terms of the information it provides. In the upper left part, we have the date, the time, and auto. This means the automatic recognition setting for ferrous or non-ferrous substrates, always metallic. File 1 is the memory file that we will set up, as we will see the battery level, the limits, and therefore the alarms. And these are the data we see both below and on the right side. At the top, they indicate the data statistics, that is, the number of readings we take, the standard deviation, the maximum, the minimum, and the average. When we actually go to record these specific statistics, we can choose to reset them or simply view them. And each time we do this, we can check for any new updates. Now let's get into the details and take a comprehensive look at the menu settings. As we can clearly see here on the screen, there is a physical keypad. This is a keypad where we have both back and enter arrows, which we will look at in more detail later on. We also have the 0 key, which allows us to reset the system directly from the keypad without the need for going through the calibration setting menu, and a delete button to erase our input. If I press this delete button, I can choose to erase either the very last entry made, all of the stored data, or just a single specific entry. If I delete everything, as you can clearly see, the enter option appears because the back and OK buttons are positioned directly underneath the 2 back and enter keys. By pressing OK, the data is deleted. I confirm the action and erase all the readings. In fact, the statistics have been reset. Stat, which then allows us to view statistics. This is a feature we will look at later. Let's enter the menu and look at the various functions. The first function is tolerance. The tolerance limits. In order to begin the entry process, always make sure to use enter, upper limit, and lower limit. These parameters are basically acting as the lower and upper limits for the system. If we choose to enter, we then have the possibility to configure a specific numerical value. The same principle also applies to the specific limit we have set. Once we have pressed the button, we officially confirm that value. The same principle holds true for the lower limit as well. It is very important to understand the process of enabling and disabling the system limits. With this feature, we can easily enable it by using the arrow keys to toggle between open or close. When the status is set to close, it means that the limits are not enabled and therefore we will not receive any visual or data indication from the system. Then we will see that by setting these specific limits, the reading will appear in red. This will be accompanied by an audible acoustic warning signal instead of the usual green when reaching an upper or lower limit. Let's enter the instrument's configuration settings. Here we have a comprehensive list of all available setting options. Starting from autosave, which refers to the process of the automatic saving of data. If this box is not checked, it simply means that nothing is saved. No data is saved when we take a measurement. Continuous mode is a specialized feature that allows us to take a series of uninterrupted measurements over a period of time. It is primarily used to observe and analyze differences in data by carefully dragging the probe across the target surface. One important thing to keep in mind when enabling this function is the necessity of having a consistently smooth surface to work on, so as not to cause any accidental damage to the delicate probe sensor. Press Enter to enable or disable. Test mode gives us the option to choose the specific measurement mode, non-ferrous only, ferrous only, or automatic. What this actually means is that in non-ferrous mode, we will measure only on materials like aluminum and copper, which are non-magnetic. In ferrous mode, only on magnetic bases and substrates, such as steel, carbon, iron, and so on. In automatic mode, it automatically recognizes the substrate. This can be interesting. Usually, it's the most commonly used option, as it also allows you to recognize the substrate. The key sound setting refers to the enabling and disabling of the keyboard sound. Now, the display accuracy is really quite interesting because this advanced device allows you to have a resolution of 1 micron, 0.1 micron, or even with the help of sophisticated AI technology, an incredibly precise resolution of 0.01 micron. In fact, if we go and take a measurement, as we can see here, we have a resolution down to 1/100th of a micrometer, something that is found in very few instruments. Next option, units. The unit setting allows us to choose the unit of measurement, either microns or mils. In most cases, microns are used for applications in Italy. The next function is time set. Here we can configure and adjust the current date and time. Again, we simply press the OK button. Basically, by using the up and down arrow keys, we can set the correct year. The specific month we are looking at, which is in this case February. The day, in this case the 11th, at the exact same time, doing the exact same operation. Once it is set, everything is ready. You can exit directly with the back button. Next, we find Files. The Files menu is the primary option available for you to select your desired memory file from the system. Within this menu, you have the ability to select up to 5 different files, and each of these files can contain 100 individual readings, which means that up to 500 distinct data values can be stored. Once you have successfully selected the appropriate file, the display screen will automatically update to display a clear message at the top of the screen stating that file number 1 is now selected. Here, an important thing is to enable autosave when we want to store data. Otherwise, it won't save anything. No data will be saved, even if we have set the file. Moving on to the next step, let's look at the language settings. We only have English available as a language option. Auto power off. Here, what do we set? Thank you. The auto power off, 2 minutes, 10 minutes, or off. We have set these two off, of course, because in this demonstration, we don't need auto power off. However, in order to conserve your battery life, it is very important to remember to set this option correctly. this feature. Brightness settings. Here we have the specific setting for the display brightness level, which goes up to level 3, which is the brightest. Keep in mind that the brighter the screen is, the more battery power it will consume. Therefore, you can easily set it to a medium level, depending on your personal needs and preferences. Calibration set. This allows you to very easily perform the calibration of the instrument. Calibration is a remarkably straightforward and user-friendly procedure. Included in the kit, as we can see right here, there are 2 zeroing bases, one aluminum base for non-ferrous materials and non-ferrous substrates, and one iron base for magnetic and ferrous metallic materials, that is, magnetic substrates. Also included are 5 thickness gauges for verification. Proceeding with calibration is a fairly simple process. Once the calibration function is selected, we have 2 steps. The measurement of the base, meaning the zeroing base, which will be the aluminum base if we are working on non-magnetic substrates, or the iron base for magnetic substrates. At this stage, we can make a choice between enabling or simply skipping the base measurement and moving forward immediately and directly to measuring the thickness. Clearly, it is very important to perform both of these measurements. So once you are inside, the only thing you need to do is carefully place the measurement probe. Then the instrument automatically performs the full calibration for you. Okay, then you move on to the measurement. Right here, before we move forward and proceed with the calibration, it is very important for us to clearly define the exact measurement of the thickness that we want to calibrate today. Why? This is because, depending specifically on our individual needs, we will select the specific thickness level closest to the measurement. The kit includes 5 different thickness gauges, which range starting from 50 microns in size up to 1000 microns, 50 in steps, 50, 100, 250, 500, and 1000. The measurements won't always be perfectly identical to one another, but they will generally be more or less similar in most cases. Let's suppose we take a standard 250 micron thickness gauge. We will place the thickness gauge onto the solid metal calibration base and carefully calibrate the specific thickness level. Still remaining under the settings menu, we will set the device to exactly 250 microns. In this case, 250. Once it's set, press OK and you'll see 250. We carefully position the probe on the thickness gauge and the device automatically begins the calibration process. Press the OK button to confirm the calibration. Back. At this point, the device is fully calibrated and ready for use. We can see there's a slight drift of 1 micron, so the calibration can also be repeated, still on a 250 micron gauge. It's a very good calibration. We can now proceed to measure other thicknesses. This is a 502 micron gauge and we get 504. A 100 micron gauge, we get a reading of 101. It is a very simple and incredibly quick process. Let's continue with the menu overview by navigating over to Reset Factory, Default Reset and Factory Reset. There are 2 distinct categories of resets that allow you to perform a partial reset, a standard factory reset where some data is not deleted, or a full default reset. This second option essentially wipes out even the stored data. It deletes all the custom settings we have made throughout the process. Now that we have finished our detailed overview of the instrument's menu system, we can move on to the very last available option found inside, which is the Info section. This specific info screen is where you can find the technical data regarding the connected probe, the current software version, and the serial number of the instrument. Let's exit out of the menu function so we can examine the individual buttons and their specific functions instead. These are the direct controls we have on the keyboard. The buttons, which we also saw at the beginning, are back, the 2 arrows, enter, 0, menu, delete, and start. So the back, enter, and arrow buttons. We have encountered these buttons because they enable us to easily navigate through and confirm our various settings. The 0 button is a key that specifically allows us to efficiently perform the zeroing process directly. without having to perform any complex calibration, but quite simply and easily by placing the probe on the base and performing the necessary process of zeroing. This can be particularly beneficial and interesting when we have substrates that have a greater degree of surface sharpness and perhaps we need to make many more points. Zero. The delete button, on the other hand, is designed to permanently delete all the data that we have stored within that selected file. A data of choice, so we go and select it. Looking at all of the data, the total number of data points we have, or just the last one, if we press on the last one, it will delete that last entry. There were 9 before, and now we have 8. An interesting thing, the statistics. If we navigate into the statistics function, we have the unique opportunity to thoroughly examine and review the data storage. In the selected file, we can view the statistics, that is the measurements we have taken, 8, the average, the maximum, the minimum, and the standard size deviations. Alternatively, we can look at every single one of the 8 values. If we had a full set of 100 data points, we could view all 100 or even look at the detailed graphical representation of the data. When we enter the graphical mode, we have the option to see the chart along with the trend line. If the list were significantly longer, we could easily scroll through the entire dataset to see more. Now let us move forward and explore different types of charts. So not only can we view the standard chart, but we can also select the type that allows us to precisely identify the exact measurement. This is particularly useful when a value has gone beyond the tolerance levels we had previously set. As for the illustration of the features and functionalities offered by this instrument, let's look closer at the thickness gauge used for industrial investments. ARW-1920s, we've covered everything. For further information or clarifications, please refer to the titles shown in this video. Thank you for your attention and see you next time.